This is a quick video on your Compass app. That's part of week two's expectations here. So let's look at the specs when you open them up. Okay, so we're going to make a Compass app. In this lesson, you will use your GPS or global positioning systems to display your latitude and longitude. You will use an orientation sensor to point north. You're going to use a canvas for drawing and an image sprite component to animate this arrow. We will also want to think abstractly about the problem of placing labels on various sized screens. All right, let's dive into this tutorial here. Setting up our user interface, we should have it looking somewhat like this. We need to add a canvas, and we're going to fill parent, and let's see if we can get that rolling right now. Okay, so I've created a new project called BSU Compass App, and what we need to do now is to bring in a canvas, and we want to set, it said here, we want to width and height to fill parent. We want to put an image sprite on there whose picture has been set to the blue arrow, so we need to download that right here. Oh, I already have a blue arrow saved right there, so I'm in good shape. I'm going to put my picture in there. Okay, we're doing good. We'll need two labels at the top of the screen that will be used for displaying the phone's orientation and location. Use vertical and horizontal layouts to position labels and canvases appropriately. I'm going to put a horizontal arrangement up here at the top to house those two labels. I want to make that width parent and make its height automatic. And I'm going to grab two labels actually, and put those in there. So we have two labels going in here. We have what is an orientation label and a location label. So we're going to make this our orientation label. We're going to make this our location label. And let's change the text to match up. So this is orientation, and this should be location. Okay, good. We're moving into this tutorial. Basic idea of this app is that we want to have an image sprite which houses that picture of the arrow and want it to always point north, and it's going to be animated to continue pointing north wherever the device is moved or the azimuth has been changed. The orientation label will report the device's current orientation with respect to due north as a number between 0 and 360. And whereas 0 and 360 represent the north, 90 is east, 180 would be south, 270 degrees would be west. And in addition, the app will also display the device's locations in terms of longitude and latitude. Okay, we have our canvas that we put in there, and we put an image sprite in the middle. And the canvas does use a coordinate system that is similar to the Cartesian coordinates. However, there is a little bit of a different. The origin, or your 0, 0, is going to be in your top left corner, whereas the x-axis is going to be increasing to the left and your y-axis increasing as you go down. So then our orientation sensor is going to be very handy here. It does have 3 dimensions. It will do a pitch and a roll and an azimuth. So we will be able to use those when we're developing our Compass app. Okay, so let's look down here at coding the compass. We need to have an orientation sensor and a location sensor. Both of these we'll be pulling out of our sensor drawer. So let's pull those in now. We have to have an orientation and a location. So your location sensor is there, your orientation sensor is there. We now have two more non-visible components at the bottom. So we have our sensors in our program, and we need to code them a little bit. Now, with our azimuth, we will need to change the heading of that compass a little bit instead, because it doesn't naturally point straight up. It points off to the left, I believe. And so what we need to do is add 90 degrees to that so that we can get it to point to the top. So let's do this right here. Going back in here. So we have our non-visible components. I'm going into my blocks editor. I'm going into my orientation sensor. And when it is changed, we need to change our orientation labels output. So it's text. We're going to set the orientation labels text to get our azimuth. Great. And we're going to set our compass arrows heading. So that is going to be our little image sprite here. We're going to set its heading to, we're going to get that azimuth and we're going to add 90 to it so that it shifts it to the top, so it points straight up. Okay, so now that we have that set up, we need to look in here now at the location. This most of the time you can use your GPS. There are three ways that we can detect a device's location using GPS, but that does require most likely a clear shot of the sky so that it can receive readings from at least three GPS satellites. This is the most accurate, but it is also one that uses the most battery power. A second way we could do this is to use a Wi-Fi signal. This might work indoors, but it does use a little less power. And it would be the location and latitude would be reported of the router. It would not necessarily be of the device. You can use your cell ID, but it is less accurate and it does lose power. So we're going to be using the GPS sensor on this. So that's our location sensor. We're going to code that up right now. So when our location is changed, we need to change our location label. And set its text to join latitude with north, longitude with west. Now I can use this little feature here to add more join boxes in. Okay, real quick, latitude north, longitude west. Latitude, let me debug that real quick. The error has to do with the fact that I'm using an emulator and my companion connection has an error with that. An emulator is not going to have a GPS feature to that, so you shouldn't see this. This coding is correct. When you're using your Android-based device, which is preferable, you should have a GPS sensor that picks that up, so we won't have that error on yours. So let's continue back to the specs a bit. Okay, it also says here we need to adjust the timer interval from 60,000 milliseconds, which is every minute, to 10,000 milliseconds, which is every 10 seconds. So the reason we want to do that is that we don't want to sit around waiting for our GPS sensor for every minute to pick up where it's at. So waiting a minute for your app to update is just too long. So we can maybe wait 10 that's 10 seconds. That is 1 second. The more often you use this application, or the more often, the lower the time interval is, the less efficient your app is going to be, basically. But the less battery efficient it will be, but it will be more efficient for the user because it will pick up the GPS sensor more often. But it is, however, less efficient on the battery because it is running it more often. Okay, so we need to run and test the app, and then we're going to enhance it. So I'm going to get my emulator up and running, and let's see what that looks like. Pretty basic. My emulator is not going to do a whole heck of a lot for this demonstration, but yeah, we just see that we have our labels and our arrow. So yep, I think we're doing what we need to do. Let's continue on now with our specs. So right now we need to enhance the UI. As we have before, we can see here that we don't have any north, south, east, west directional letters on our user interface. So that could be kind of confusing. We want to make that less so for the user. Now, the idea again is that north is going to point to the front, and then we'd have east to the user's right, and west to the left, and south behind. Using the canvas.drawText method, we need to draw letters in the proper positions on the screen. So we can see there's a north, east, south, and west directional letters on the user interface. And we want the directional letters to always be visible, so you will want to do the drawing in the when screen1.initializes block. Let's continue to read a little bit because this has more information. Designing for all devices. It's important to consider that different devices have different screen sizes. So you shouldn't hard code in your north, east, south, and west coordinates like it is explained here. So the X and Y are going to be hard coded. So now it may look good on your device, but if we pop open a device that has a larger or smaller screen, those coordinates will be hard coded in, and that north may or may not find its place in the top center like you would like. So what would be better is to do more of an abstract thought about screen sizes. We do want our north to be at the very top, halfway through the width. So we can use the canvas.width, gather that size of the user interface, divide it in half, and that will be your X coordinate. And then we can hard code in 20 so that it's just a little bit off the top. So this way, no matter what device the app it runs on, it will be in the north will be in the top middle, about 20 pixels down. So let's build our next set of letters here. So we're going to go into our user blocks interface. And remember, this is going to be when the screen one initializes. We want to go into our canvas.drawText. Come on. Okay, canvas.drawText. We want the text to be a north. We're just doing the north one right now, so it's going to be an N. And we want to place that halfway on the top, so we take the canvas width and we divide it in half. Now our Y coordinate, we can just hard code this one in because 20 from the top is 20 from the top on all devices, so that's good there. Now you'll need to do one for a south, east, and west as well. Great. So that is the initial piece here. Let's see what that looks like when we run that on our. So we do have our directional label of a north at the very top there. So that's pretty good. Let's take a look. I do know that we are going to be moving this assignment into variations, and it will be one of your homework projects. So let's take a look at that here underneath assignments. We have your Compass app variations. This will be due next week. So we need to finish adding those labels. So we have a north in there. We need to add the east, south, and west like I had talked about. We need to change the font color and size of those letters, and we need to format our labels, your orientation and location label, so that the orientation has a 2 digits decimal after the decimal point, and the location label has a 4 digits after the decimal point. And then here is your extra credit piece. Please let me know if you've attempted this so I can look for that in your code, and your submission page. Again, all of these are going to go create a homework tab and portfolio, name it Compass App Variations. So let's go in just a little bit more. I want to talk to you about how to find some of that stuff in your math drawers, where I would say you should look for, you should be looking in your math drawer for those decimal placement things. So if you want to set your decimal places up, you might be looking right about here. Okay. Well, that's a little bit about your Compass app. Hope that helped.